Now we have been proving, and this question has the word solve. Okay? So don't try to prove this. You will not be able to. 2 sine x is not equal to 3 plus 2 cosecant x for all values of x. But what a solve question is looking for is what specific values of x does it work? Well, one thing that we're going to find with our solving questions is that we can use our identities as part of the strategies for solving them. And one of the main strategies that we're going to look at is if you can write everything with the same trig function, it's going to be easier to solve. Right now, this question A has a sine and a cosecant. Is there a way to write that equation so that you were only using one trig function instead of 2? Yes. What could you change? You could change the cosecant to 1 over sine. Now if you do that, now our equation is only with one trig function. It's like having an equation with only one variable. Now you can use all of your algebra skills to solve this. And so we're going to combine our algebra skills from rational functions, quadratic functions, all of those together to solve. What would you do if you had a question with an x on the bottom like that? Like we have sine x in the denominator of a fraction. What would you do if you had that just as an equation here? Use x instead. If this was your equation, or it's 2 over x. If you had that, what would you do? Sorry? Right. If we multiply by x, what does that do? It gets rid of that fraction, right? And then maybe our life is a little bit easier. Now, when you multiply by x, depending on your system of how you do this, basically what you're doing is you're multiplying both sides by x. So we're going to multiply this side by x, and we're going to multiply this side by x. Now, most people just write it like this, but it's important to know, why do we multiply 2 things by x on one side and only 1 on the other? It doesn't quite feel like we're doing the same thing. Well, you are, because when I multiply each of these by x, it's because if I multiplied this whole side by x, if I put brackets around it, you'd have to distribute that x. So in the end, when you multiply both sides by something, every term gets multiplied by that value, because that's what distribution would do. So here, if we multiply everything by sine, multiply by sine, each term by sine, well, here our sines will cancel out, and we'll be left with 2 sine squared x equals 3 sine x plus 2. It's a quadratic. So notice how all of our algebra skills that we've developed over time come into play. At first, we had to use our algebra skills with rational equations and have to know how to multiply to get rid of that fraction. And after doing that, what pops up? A quadratic equation. And then we use our skills for those. What do you do with a quadratic equation? Set one side equal to 0. And either factor or use the quadratic formula. Does this one factor? Well, if it were to factor, it's an easy one, because 2 sine squared, what has to be the first ones? Has to be 2 sine and sine. That's a guarantee. And with the last number being a 2, means that these last two have to multiply by 2. So it's either 2 and 1 or 1 and 2. Okay, and it has to, once you look at your outside ones and your inside ones, you have to make 3. Can you see why 2 and 1 is going to be bad? Because my outside's 2, my inside's 2, and 2 and 2 never make 3. But if I make my outside 2 and my inside 1, I'm going to get 4 and 1. And I need to get a minus 3, so I would want my 4 to be minus and my 1 to be plus. So what does that give us? That gives us that sine x could equal 2, and here sine x could equal negative a half. Either those on your pie plate? The 1/2 is what family? Pi over 6, and because it's negative, quadrants 3 and quadrants 4 is 2 on our pie plate. No, so how do we do that? Have to get a reference angle with our calculator, or if this question would be a non-calculator one, how do you know that this side is, well, I'll just write not possible. How do we know that? Because sine of x is bigger than 1. Now, I solved between 0 and 2 pi. Again, you just sort of get in the habit of solving between 0 and 2 pi. We should check, is that what was asked for? Yes. So if we go back and look at our equation, yes, it was asked for to solve between 0 and 2 pi. Excellent. Now, part B. Sine x equals cos x. There's two ways that students solve this one. Sometimes they just think about their pie plate and say, is sine x ever the same as cos x? Yes, when? At pi over 4 in quadrant 1. Anywhere else? In quadrant 3 where they're both negative root 2 over 2. So some students say, I know from my pie plate that the answer is pi over 4 and 5 pi over 4. And we're done. That's a really quick way, if you can see that. Other times we say, well, the strategy we used in the first equation was we tried to write things as a single trig function. There's no way to change just sine to cos and just cos to sine. We can change sine squared to 1 minus cos squared. We can't change sine to 1 minus cos. So in this one, another way of making this a single trig function is if you divide both sides by cos. Can you see that you would get this? Can you change that to a single trig function? Yeah, that's just tan. And when is tan equal to 1? Pi over 4 family. When is it positive? Quadrant 1 and quadrant 3. And you get those same answers. Again, yes?
Are we allowed to use our pie plates for this one?
Yes. Yay. And for practice, question number 10 is another solving one.